Every single digital world you've ever explored, every app you use every day, it all boils down to microscopic switches. It's kind of crazy to think about, right? Well, welcome to this explainer on the Silicon Ascent. Today, we're demystifying the incredible technological stack that transforms a single, humble switch into a fully realized virtual reality. So think about the very device you are using right now to watch this. How in the world does it actually turn invisible electrical signals into, say, falling Tetris blocks? How do microscopic logic chips play a game? To most of us, it kind of just feels like pure magic happening inside a black box. But beneath the surface, it's built on a beautifully structured foundation. Here is the roadmap for our ascent today. First, the abstraction ladder. Second, the foundation of logic. Third, speaking to silicon. And finally, building virtual worlds. All right, part 1, the abstraction ladder, demystifying the black box. You see, a computer isn't just one giant confusing machine. We use this concept called an abstraction ladder. It's basically like driving a car, right? You absolutely don't need to understand the thermodynamics of a combustion engine just to turn the steering wheel. Abstraction lets us view computing as a series of neat developmental layers, built super carefully on top of one another, which completely hides the massive complexity underneath. This brings us to the brilliantly named NAND to Tetris philosophy. It visually maps out a clear 6-step climb. We literally start at the absolute bottom with raw NAND gates, evolve those little guys into logic chips, and combine them into a CPU. From there, we step up into assembly language, slap on an operating system, and finally arrive at a fully functioning software application like Tetris. Step by step, we are building a computer completely from scratch. Moving right along to part 2, foundation of logic, the physical ground floor. It really all begins with a single, humble NAND gate. This is the universal building block of literally all modern tech. The entire highly complex relationship between your favorite video games and the physical hardware running them, it all originates from these incredibly simple foundational switches, just checking if signals are true or false. Now, obviously, a single switch doesn't do a whole lot on its own, but when you combine those initial NAND gates, you get logic chips that can actually handle basic math and memory. By incrementally stacking these simple gates together, millions and billions of them, human ingenuity builds up to the central processing unit, the CPU. So the physical brain of your computer is, at the end of the day, just a masterpiece of interconnected microscopic switches. And here is the massive pivot point in our whole ascent. On one side, we've got our physical hardware foundation, tangible things like NAND gates, logic chips, CPUs. But on the exact opposite side, that physical foundation of wires miraculously gives way to the virtual realm of code, assembly, OS, and apps. It is the definitive dividing line between the physical world and the digital world. Which leads us perfectly into part 3, speaking to silicon, the software bridge. So, moving up the ladder, we officially cross over from the physical to the virtual and hit assembly language. This is that first, absolutely crucial translation step. It takes our human logic and translates it into the raw, binary ones and zeros that the silicon can actually understand. Without this direct bridge, we'd honestly have no efficient way to tell the CPU what to do. Sitting right above that assembly code is the operating system. You can think of it as the ultimate traffic cop. It manages all the underlying hardware layers beneath it, processes the assembly language, and supports all your high-level applications. It's doing all the heavy lifting to create a stable environment, so your software runs flawlessly without you ever having to worry about what those microscopic wires are doing down below. And finally, part 4, building virtual worlds, the payoff. So when you look at a sophisticated, functional game like Tetris now, your perspective should be totally shifted. Every single falling block, every line you clear, it's actually a beautifully translated cascade of logic stretching all the way back down that abstraction ladder. The game relies on the OS, which relies on assembly, commanding a CPU built from logic chips, which are made of billions of microscopic NAND gates. It's an intricate digital universe built entirely from the ground floor up. To wrap up this explainer, just take a second to really appreciate the sheer scale of the technological stack powering the very device you are using right now. There are millions of invisible ladders working simultaneously just to render this exact explainer on your screen. It's mind-blowing. And as our silicon foundation becomes unimaginably advanced, we really have to ask ourselves, what impossible new layers of abstraction will the future of computing bring? Where on earth is this ladder going to take us next? Keep exploring, and thanks so much for joining me.